Now Kerberos is another single sign-on technology, and we're actually going to go deeper into Kerberos because you can get questions on Kerberos that ask about specific pieces and parts of it. So Kerberos is one of the technologies I cover to more of a depth than the other single sign-on technologies. Kerberos has been around for a long time. It was mainly used in the Unix world for authentication. It's based on symmetric cryptography. Now, if that doesn't mean anything to you right now, we will get into that when we hit the cryptography domain. But that is something you need to know. The characteristic of Kerberos is it's based on symmetric cryptography, and we'll look at how that works. So what are the main components within Kerberos? Well, we need to have a KDC, which is a key distribution center. That's the server that has all of the users' accounts, their ID, their credential sets. So it's an authentication server, but it has everybody's keys. And some people get confused when we talk about keys in Kerberos. And really, you could think of a key as a password, because a lot of times a password is used as a key. Because if you think about it, a password is really just broken down into binary value, and a key is just binary value. So, and we'll talk a little bit more about that. But so there's a KDC that has all of the keys, and we don't use the word like users and services in Kerberos. We say principals. And principals are the users and the services. It's anything that has to authenticate to the KDC. Those are called principals. Now the KDC is responsible for a realm, and a realm is a set of principals. If you're, it's like a domain. You can think of it as kind of like a domain. One domain controller is responsible for all of these resources. So these are the main components we need to know about the KDC. The principals are the ones that are going to use the KDC by authentication, and then collectively they're called a realm. So a KDC can be responsible for one or more realms. It doesn't have to be just one. It can be responsible for more than one realm. Now within the KDC itself, there's two main services that we have to understand. There's an authentication service, and there's a ticket granting service. The authentication service is where the users, the principals, are going to send over their credential information to get authenticated. And then the ticket granting service is going to allow for these users to be able to communicate to other network devices. So let's see how this takes place. Within a KDC, we have an authentication service, and we have a ticket granting service, a TGS. Within the KDC, again, that's where all the principals' credentials are. Now, in an environment that is using Kerberos, a principal cannot talk directly to a principal. So I cannot just send over a print job to a print server. I have to go through this whole authentication process. No principals, they don't trust each other, so they can't directly communicate. So what happens is I come in 8 o'clock in the morning, I sit down at my workstation, I put in my username and password. My username gets sent over to the authentication service. Not my password, my username. But I have typed in my username and password, and I don't really know what's going on in the background. So I type in my username and password. My username goes over to the authentication service on the KDC. Now the authentication service looks in its user account database, says, is there Sean Harris? Yes. And it looks up my key, my secret key. It will take my secret key, and it will encrypt a ticket. It will encrypt a ticket called the TGT. Now, when it gets to my system, if I've typed in the right password, that password is used to decrypt that ticket, and now I'm authenticated to my system. So again, I come in 8 o'clock in the morning, I type in my username and password, my username goes over to the authentication service. If I'm in the database, it gets my key, my secret key, and a ticket is created that's encrypted with my secret key. It goes over to my workstation. My password is cached because I've already typed it in. If I typed in the right password that is used as the key, it will decrypt that ticket, and now I'm authenticated to the system. Now I can get on my system, do my files, but I can't go and talk to any network resources yet. I've just authenticated to my system. So when I want to talk to another principal on the network, I have to go and communicate with the TGS. And basically what happens is I send over a ticket to the TGS and to prove that I've already been authenticated. Basically, I send over this ticket to the TGS and say, look, I've already been authenticated. I need to talk to the print server. There's a lot more information to it, just like everything. We're going 1 inch deep on every subject. So the TGS will validate that ticket that I send over. And what the TGS is going to do is create another ticket. Once it's validated my ticket, it's going to create another ticket. Within that ticket, there's going to be 2 session keys. So really 2 instances of the same key. Now, what's the difference between a secret key and a session key? Well, a secret key is one that's static. You'll use it over and over again. It's just like your password. You'll use your password over and over again until you change it. That's what a secret key is. A session key is only good for 1 session. So once a session key is used, it's destroyed and it's not used anymore. So again, I have authenticated to the KDC. It sent over encrypted ticket. I put in my right password. It decrypted a ticket. Now I need to communicate to the print server. I send over a ticket to the TGS and say, look, I've already been authenticated. Now I want to talk to the print server. TGS is going to create another ticket. It has 2 session keys in this ticket. Now, one key is encrypted with my secret key, and the other session key is encrypted with the other principal secret key. So we have one session key that's encrypted with my secret key, and we have another session key that's encrypted with the print server's secret key. So this ticket will come to me. I will use my secret key to decrypt and extract that session key. Remember that my secret key could be my password, and it's already cached. I've already typed in my password, so it's cached. So my secret key, my password, is used to decrypt and extract a session key. Now, I send that ticket over to the principal I want to communicate with, the print server. The print server does the same thing. It takes its secret key, decrypts, and extracts the session key. Now, what has gone on so far is that the print server knows that a trusted entity is vouching for me. I can't directly talk to the print server because it doesn't trust me. All the principals trust the KDC. So when I send a ticket over the KDC and say, hey, I need to talk to the print server, the KDC is going to make a ticket that is one of the keys is going to be encrypted with the print server's secret key. If the print server can properly decrypt and extract that session key, that means it came from the KDC. Only the KDC and the principal have a copy of their secret key. So far what this has proven is that this ticket actually came from the trusted source, the KDC, because nobody else should have the secret key of the print server. So one more time, I authenticate and I'm on my system. Once I need to communicate outside to the network, I will send a ticket over to the TGS, and the TGS will make another ticket. Now, I said that the ticket contains 2 session keys. Remember, session keys are only good for one session. One session key is encrypted with my secret key. The other session key is encrypted with the other principal's secret key. Now, there's one more piece that actually goes into this ticket. It's called the authenticator. The authenticator comes from the KDC. It has identity information about me. You know, this message is coming from Sean Harris. And it has sequence number and a timestamp, and it's called the authenticator. Now you see the authenticator is encrypted with the print server's secret key. Now, when the ticket comes to me, I do what I said before, which is I take my secret key and I decrypt and I extract the session key. Now I'm going to add information to that authenticator. I'm going to say this is from Sean Harris, and then I'm going to encrypt it with my session key that I just pulled out. So what we have is that I told the KDC, look, I need to do a print job. I need to communicate with the print server. It created, the KDC, the TGS service that's on the KDC, created a ticket with 2 instances of the same session key. One's encrypted with my secret key, one's encrypted with the other principal's secret key, and it also put this information that's called the authenticator, and it encrypted it with the print server's secret key. I got the ticket, I used my secret key to extract the session key, then I put some information in the authenticator, basically, you know, this is Sean Harris, and I encrypted it with the session key. Now the ticket, just like I said before, goes over to the print server. It uses its secret key to extract that session key. If it can actually extract that session key, it knows that it came from the KDC. Now it needs to know that I am who I said I am. And it's going to use that session key that it just extracted, decrypt the authenticator information, and read what I put in there. So like, let's say it says Sean Harris. Then it's going to use its secret key and decrypt what the KDC put in there, and it's going to compare the two. If the KDC says this is coming from Sean Harris and I say this is Sean Harris, the KDC is vouching for my identity, and now the print server will take my print job.